The next thing we need to talk about before we can put the op amp in a circuit and start doing analysis is the linear and the saturated regions for the operation of the op amp. So remember, if I call this VA and VB, so this is input A and input B. Suppose this is going into the inverting terminal and this is going into the non-inverting terminal. Recall that V out is defined as our amplification factor, right, our gain, times the difference between these two. So that's VD for voltage difference. So this is going to be VB minus VA. Okay, so the thing about these power supply inputs is that this is actually going to bound our output, all right? So our V out, this part here, it can't be greater than whatever our positive VCC is. So we can't have that, and it can't be less than whatever our negative VCC is. Okay, so since our V out is bound, it's basically capped by these input values, we need to make sure that negative VCC is less than or equal to our V out and less than or equal to our positive VCC. All right, great. So then if I just take this definition here and I substitute it in for V out, this means that I need my negative input voltage to be less than or equal to gain times VB minus VA, so the different voltage difference between the inputs, and that has to be less than or equal to positive VCC. Okay, great. So then what I can do is I can divide everything by this gain here. So I need this to be true. So VCC, negative VCC divided by the gain has to be less than or equal to VB minus VA, and that needs to be less than or equal to positive VCC divided by the gain. Okay, so what we have here is we have some bounds for the difference between our input voltages. So if I put this on a graph, it's going to look like this. So suppose we make the plot of V out. And if this is VB minus VA, we just said that we need to have this greater than negative VCC divided by the gain, and we have to have this smaller than positive VCC divided by the gain. Okay, so these are our bounds on VB minus VA. So as long as it's within this region, then we're going to have a linear amplification factor. Okay, so the slope of this is going to vary depending on what your gain is, but it's going to act like a linear circuit device. So what happens if our VB minus VA is smaller than negative VCC over A? Well, so what happens is we said that the output gets it gets clipped because it's bounded by this value here. So clipped means instead of having this amplification factor continue in a linear fashion, this is just going to get bounded here by negative VCC. Okay, so we cannot have an amplification that is lower than negative VCC. So it's the same story up here. If the difference between VB and VA is greater than positive VCC over A, we're going to have a clipping because this is bounded by our power supply voltage. So this is going to be a maximum of positive VCC. Okay, so that means that this here, I can kind of draw this out. This here is going to be our linear region. So as long as we meet the specification that the difference between our input voltages is within these two bounds, then we'll have a linear amplification. But Otherwise, we're going to get voltage clipping, and that's just going to be whatever our positive VCC is in the positive saturation region, and whatever our negative VCC is in this region, which is called the negative saturation region. Okay, so sometimes you'll be asked to evaluate op-amp circuits that are in these saturation regions and state what are some requirements for bounds for our input voltage in order to ensure that we are in this linear region. Or you might be told that the op-amp is operating in, say, like the negative saturation region, and then you need to make some determinations of the circuit there. So I just wanted to give you a definition of what this means. This is the linear region. This is kind of what our goal is. We want to make sure that the op-amp is actually amplifying in a linear way. And if that doesn't happen, then we're in the saturation region, and that's when it gets clipped by positive and negative VCC. So let me know if you have questions about that.